Let's start with the simplest one, bus topology. In a bus topology, all devices are connected to a single central cable called the backbone. When a device sends data, it travels along the backbone and every other device can see it. The data contains the destination address, so only the intended device processes it. Bus topology was popular in the early days of networking because it was simple and used less cable than other options. But it has serious drawbacks. If the main cable breaks at any point, the entire network goes down. It's also difficult to troubleshoot because a fault anywhere affects everyone. Performance drops as more devices are added. And because data is visible to all devices, security is weak. Today, bus topology is rarely used in modern networks, but understanding it gives you a foundation for more complex topologies. Next is star topology, the most common topology in the world. In a star topology, every device connects to a central device, usually a switch or a router. All data flows through this central hub. If you look at your home network, you're likely using a star topology. Your phone, laptop, TV, and gaming console all connect to your router. The biggest advantage is reliability. If one cable fails, only that device loses connection. The rest of the network keeps running. It's also easy to add new devices, just plug them in. Troubleshooting is simple because you can quickly identify which cable is causing problems. The downside is that if the central hub fails, the entire network goes down. Star topology also requires more cable than bus topology. Despite these drawbacks, star topology is the standard for home and office networks today because of its balance of cost, reliability, and ease of management. Ring topology connects each device to exactly two other devices, forming a closed loop. Data travels in one direction around the ring, passing through each device until it reaches its destination. This means every device acts as a repeater, regenerating the signal before passing it on. Ring topology was popular in the 1980s and 1990s with networks like Token Ring and FDDI. One advantage is that performance remains consistent even under heavy load because data flows in an orderly manner. However, if any single device or cable fails, the entire ring breaks. Modern ring networks use a dual ring design where data flows in both directions. If one ring breaks, the other takes over. This redundancy makes ring topology very reliable in specific applications like metropolitan area networks and some industrial control systems. But for most modern use cases, star topology has replaced ring topology due to easier maintenance. Mesh topology is the most reliable but also the most expensive. In a full mesh topology, every device is connected directly to every other device. If you have 5 devices, you need 10 connections. With 10 devices, you need 45 connections. The number of connections grows exponentially. This makes full mesh impractical for large networks. However, partial mesh topology is more common. In a partial mesh, only critical devices are interconnected while others connect to just one or two. The Internet itself uses a mesh topology at its core. Major routers around the world are connected to multiple other routers. If one connection fails, data can take an alternative path automatically. This is what makes the Internet so resilient. Mesh topology offers the highest level of fault tolerance and redundancy. It's used in military networks, airline reservation systems, and data centers where downtime is not acceptable. The trade-off is high cost and complexity. Tree topology, also called hierarchical topology, combines elements of star and bus topologies. Think of it like a tree. The top of the tree is the root, usually a powerful central device. Branches extend from the root to intermediate nodes, and leaves extend from those nodes to end devices. In a corporate network, you might have a central server at headquarters, regional switches in different cities, and local switches in each office. This hierarchical structure mirrors how organizations are structured. Tree topology is scalable. You can easily add new branches. It also allows for efficient management because traffic can be segmented. Different departments can have their own local networks while still connecting to the main backbone. The main disadvantage is that if the route fails, large portions of the network may become unreachable. Tree topology is widely used in enterprise networks, university campuses, and large organizations. Finally, hybrid topology combines two or more different topologies. Most real-world networks are hybrid. For example, a company might use star topology within each department, ring topology between buildings on a campus, and mesh topology for its critical server connections. Hybrid topologies give network designers the best of all worlds. They can optimize each part of the network for its specific needs. A factory might use ring topology for its assembly line robots, star topology for its office workers, and mesh topology for its security systems, all connected into one unified network. The downside is complexity. Hybrid networks require careful planning and more devices like routers and switches to manage traffic between different topology segments. So which topology should you use? For a home network, star topology is ideal. For a small business, star topology with proper switches works perfectly. For large enterprises, a tree or hybrid topology provides scalability. For critical infrastructure, mesh topology offers the reliability you need. And for specialized industrial applications, ring topology may still be the best choice. Understanding network topologies helps you understand how the internet works, how data flows, and why some networks are faster and more reliable than others. Whether you're setting up a home network or designing a global infrastructure, choosing the right topology is the first step to building a network that works.